Everyone's saying that this salted caramel frosty from Wendy's is turning green after like a few days. I don't believe you. Like, I just don't believe you.
No way. It's only been, I think it's probably only been 2 days.
Well, I mean, that's green. I mean, that's neon green.
There it is. So I got this around Friday at lunchtime. Now it's Monday at lunchtime. It's kind of gone through a couple phases. It seems to be thicker. It's a little bit lighter green. It went up to like a neon yellow green, and now it's this kind of like pale green color. Let's try to figure out what the green is. In this case, we need it again, put the green frosty in the -80 for long-term storage. Alright, we got the 3-day-old green Wendy's salted caramel frosty in the lab, and it does got a bit of a stink to it. I've cut off the pipette tip because this is some thick stuff. And so we're going to take some of this green frosty. We're going to try 3 different things to isolate this green color. It is kind of faint, so I'm hoping to concentrate it. Stuff has turned into like a syrup. I think something's just kind of oxidizing over time, maybe. So I've taken three pulls of this stuff. I mean, it does look real green. I'm going to mix it with 50% methanol, 50% acetonitrile, or 50% isopropanol. I don't know what's going to work better. Alright, spinning it up. Alright, so you can see it is crashing out in the acetonitrile on the right, but it's the color's staying in the crash. It's like all the protein and fat, probably, and sugar. The isopropanol one looks pretty promising. The methanol somehow got really light. That's bizarre. Alright, so there's it mixed in isopropanol. There it is mixed in acetonitrile. Ooh, that one looks like the best so far. And then there's it mixed in methanol. Fading in methanol. Kinda brighter in isopropanol. It's interesting. And it looks like it's kind of like maybe extracting out the acetonitrile. I'll have to spin these guys out and see. Alright, so the methanol sample does look like it has the green in the methanol layer and everything else precipitated. Okay, bizarrest result so far. This is the acetonitrile. It's split out into 2 layers with an interface. I mean, this should be only miscible solvents. Like, why is there 2 layers? That's so bizarre. The isopropanol is the same thing, if anything better. We have more green in the top and everything else precipitated. So, easiest is probably the isopropanol. Alright, so I pulled a little bit of the isopropanol liquid layer off the top. That does have that green color. I don't like running straight isopropanol in the system, so I'm going to dilute it with 2 parts acetonitrile, see if the color still remains. Good thing I did that. As soon as I added the acetonitrile, the whole thing turned milky and crashed. We can spin that back out, but I'm just going to switch to the acetonitrile fraction. And you can see I just spun it really quick to see. In the acetonitrile one, the green pellets out at the bottom, so something's up. Alright, second attempt. We're going to try to pull from that acetonitrile bottom layer. So strange when you get immiscible layers into miscible solvents. Alright, so we got a bit of it off the bottom here. See, so we got a little bit of it off the bottom here. You can see that it is still green. There's little chunks in there, though, so we're going to have to dilute this out, spin it one more time. That's crazy. The bottom acetonitrile layer is not miscible with acetonitrile. So the acetonitrile is going to the top. What is this thing? It's dissolved probably in the sugar. I mean, that's the only thing I can think that's splitting out because of all this corn syrup. So it's in the sugar layer. Very bizarre. Been messing around with this. I didn't really know what to do. We're just been, it looks like it's in like a sugar layer. So I mixed the methanol and the isopropanol one, and I added some water, and I added some ethanol, and now we got them back on here. This is a lot harder problem than I thought it'd be. So anyways, we're going to try to get a mass on this green compound. I still got a bit of it left. Here we go. Here's a water fraction. It almost looks like in the water fraction we have some in solution, but a lot of it just kind of crashed out. Crazy. In the ethanol fraction, okay, it's a little bit more soluble. Still got a little bit of a green tinge. I think it's a concentration that we could run. For all that work, here are my 2 greenish tinged fractions. You can kind of see there's a little bit of green color in them still. We're going to take this over to direct injection. So the only thing I feel comfortable putting these on is this direct injection ion mobility system, no column. I'm going to use a needle and a syringe and just run it right in. Man, it fired right up. You gotta love this thing. So anyways, this is ion mobility, direct injection. We're gonna go ahead and run this guy out and see what we get. Alright, unknown frosty green, start, positive mode. We're gonna add that drift time function. Don't forget to do that. And we'll go ahead and just start this thing. then we're going to go ahead and use the syringe, pour it on top, and put some of this greenish solution into the syringe. And then we'll go ahead and run that in. You can see, there it is, beautiful drift time. Really nice, sharp looking data there. I bet it's a bunch of stuff that we don't care about. So we ran that one in. Here's our data, unknown frosty green. We got sugar at 365. That's pretty well known, and 381. And then we have 527, which this could be another part of the sugar. It's typically what I see there. And 689. So these are all just... Alright, I'm surprised you guys made it this far, but this video has been tough to make. I cannot figure this color out definitively. Here's all the masses. Feel free to search them. Try to figure things out if you want. HMDB, MZMine, search masses. But this is going to be my best hypothesis to what's going on here. So I'm zeroing in on this mass at 203.0818. Alright, so this 203 mass I think could be pyrene. I don't want to confirm this though because I do not have enough data to confirm this. PAHs, this is polyaromatic hydrocarbons, can be in caramel flavoring. It's actually smoke flavoring and caramel flavoring are still kind of just like crude products that are made by like caramelizing sugars. And so this is called like sulfate ammonium caramel. It's a caramel coloring and flavor in food, and it's made by heating up carbohydrates in the presence of sulfite and ammonium compounds. It's called acid-proof caramel, and it's soft drink caramel. It's a food ingredient allowed in the United States. So it's in frosting, soft drinks, and I think this would probably be the color and potentially the flavor of the Celtic Caramel Frosty. So anyways, my best guess is some sort of PAH from the caramel flavoring. Don't know for sure, but that would, in theory, it could make a green color if there was enough of the same one. But it's a very bizarre situation, and I don't think I'm fully to the bottom of it.